Okay, so 6.2 is on radicals and rational exponents. So first, let's review a little bit about what you already know. So first of all, we should know that this is something like 2 to the third power, or 2 cubed. And then that would be 2 times 2 times 2. So to uncube a number, we do what's called cube rooting, which is just means like that, and you put the 8 underneath, and that answer would be a 2. Because what this symbol is doing on your calculator is trying to figure out what times what is going to be 8, and that's the answer, would be 2. So it would just be like if you're square rooting a number, if we have like 81. Well, the square root of 81 is just what times what is 81. So we don't normally put this little 2 there, but that's what it's doing. It means what times what is going to be 81. Well, 9 times 9 is going to be 81. The, I guess, thing to remember is if it's a odd root out here, it's just going to have one answer. Like 2 is the only number that you can get when you take the cubed root. But when you do the square root of 81, this could be 9, or it could be a negative 9. So if you have, for example, the fourth root of something, well, the fourth root, for example, 25. This isn't going to work because 25 is not a perfect cube, or I guess a fourth. But what that would do on your calculator is figure out what times what times what times what is going to be 25. And again, that would be positive or negative because it's an even root. Even roots have 2 answers. Odd roots only have 1 answer. So instead of having like finding the square root, finding the cube root, finding the fourth and the fifth and the sixth, we call it finding the nth root, which just means you can find the nth number of roots for any single number. So the format that you're going to use is the square root of a to the nth root. And a is just your base. So whatever number they give you, and then the n is going to be your root. So it means the root of whatever number you're finding. So for example, if we wanted to do the square root of 9, that's how it would be written. Really, it just means what times what is 9, which is going to be a 3. So the answer would be 3, or negative 3, because negative 3 times negative 3 is 9. So again, your format is going to be that square root of a to the nth root. So we're going to practice that because that's what you're going to have to do on your assignment. So the first thing it might say is find the indicated root. And it will say, it will give you the root. Like let's say, for example, it says n equals 3 and a equals negative 27. Well, first of all, it just means put it into the formula up here. So if this is my format and they're telling me the n, well, it literally means, if again I've got the n and the a, it means I'm going to replace the n with a 3. So I'm going to have a little 3, which means we're doing a cubed root. And then the a is a negative 27. So you have this button on your calculator. You could easily do this on your calculator, but what your calculator is figuring is what times what times what is going to be a negative 27. And when you type that in your calculator, it's going to be a negative 3. So the answer is negative 3. And there's only one answer because my root is odd. Okay, another example says our nth root is 6, and our base is 64. So looking back up here, I have the nth root of a, and I'm literally going to plug in my numbers. So you have the 6th root of 64. So again, what you're trying to figure out is what times what times what times what times what, 6 of them, to get to 64. So again, that gets a little bit more difficult to think back that far. But again, you have this button on your calculator. You can type that in and I will show you how to do that. So when you hit it, it's going to say 2. However, you need to realize that this is an even root. So if it's an even root, that means it's got to be a positive or a negative. Because I could put a positive 2 times 2 times 2 times 2 times 2, or I could put negatives in front of all these and it would still work, and it would still be 64. All right, another way to write these roots is as a rational exponent. So anytime we have something like the square root of a, it could be rewritten as a to the 1/2 power. And then let's say we have the cube root of a. Well, that could be a to the 1/3 power. You should see a pattern here. The cube, or the fourth root of a, could be rewritten as a to the 1/4. So do you see the pattern? If it's being square rooted, you just take it to the half. If it's cube rooted, it's the third. If it's the fourth root, it's the fourth. And again, a lot of these are just going to be you evaluating, and again, your calculator could do this for you. So it shouldn't be too difficult, but know that it could be written that way. So for example, if we have the 6th root of a, we just know that that's a to the 1/6. And again, this is called rational exponent form. So anytime it's asking you to write it in rational exponent form, that's what they mean. And again, rational just means it's a fraction. It's not. It doesn't have to be a whole number. So fractional exponent, fractional exponent, fractional exponent. So anytime it's asking you to write in rational exponent form, that's what they mean. Okay, so a couple of examples on rewriting expressions in rational exponent form. If we have something like the square root of 10. Well, again, a rational exponent means we have to write this as a fraction. So the first thing I'm going to do is I'm going to put my root in there. If I'm just square rooting, I'm trying to think what times what is going to be 10. Well, that could be rewritten as just the base to the 1/2, because all I'm doing is I'm taking the root and I'm putting it as a fraction. So you would just, you would just write it like that. Another example, if we have the 5th root of 34. Well, again, you take the base and you just take the power, or the root over here, and you write it as a fraction. And you could type this into a calculator and this into a calculator, and they should equal the exact same thing. But again, this just tells you to rewrite. You do not have to evaluate on those. Okay, now let's say you're going the other way. So for example, if we have 15 to the 1/3 power. Well, 15 to the 1/3 power just means the cubed root of 15. So now you're just going the other way. Or if we have 140 to the 1/8 power, well, now we're just taking the 8th root of 140. So it's just being able to go back from one form to another.